Good afternoon, good morning. I hope everything is running. Yeah, I think we are live and sound is okay. Yeah, this is the second episode of the. Oh, my camera is off now. Okay, so I am back. I don't know what happened. The camera out of the blue stopped working. Now it seems it works again. Okay, so this is the second part of the active probe design stream. I don't know. No. To be honest, this is not to be the last session when working on the active probe. Why? Because I think there is so much things to solve, to answer, so much questions when starting. I can start speaking about powering the original design. We can open at least the original schematic. Manufacturing schematic prints. Yeah, you can see, I hope you can see, there is a barrel connector J4, and maybe I should open. No. Let's stick with the schematic. So there is a barrel connector powering the negative charge pump IC, charge pump power supply. Then there is a dual positive and negative LDO, low noise, for powering the op-amps. There is VCC as a positive output and VEE as a negative output. A bunch of decoupling capacitors, probably for all of the components. Frankly, I don't like this type of schematic structure because you don't know when you are. Yeah, we are users of this open source design, and we need to know where to place each decoupling capacitors. There is a battery of some decoupling capacitors, and there is none of them near the high-speed op-amp or this general purpose op-amp. There is nothing. Here is the decoupling capacitor for output, for both outputs. This is how it should look like. This is a mess, and I don't recommend creating such a mess schematics. There is plenty of space near the VCC and VEE power entries. I don't know why there is none of them. Anyway, so what should be the power entry point? Should I keep the parallel connector? Should I change it to some header, some screw terminal? Should I change it to some battery? As we discussed last time, 5 volts is the power, the input power, the input voltage level. So yeah, there can be like 3 AA cells, like on the differential probe for instance, key side. There can be a DC power input, like on some current probes. It reminds me that I have a new current probe. Let me let me check. I'm back in Yeah, I'm sorry for the delay. Yeah, this is how the design stream works. Yeah, everything is uncut, unfiltered. I have a barrel connector to USB cable. Nothing I want to use in the future because there is USB Type A connector at the end, but there is a barrel connector. So it seems that I can use the same DC barrel connector, like the most common one. And I wanted to check the power adapter on my current probe. But believe or not, at the moment, I don't know where the package is. And I don't want to make the stream, today's stream, more messier than it actually is. So I will keep the barrel connector for now. That's one question answered. Good morning, afternoon, probably. 𝗤𝗲𝗀𝗃𝗍𝗃. I'm not sure if I pronounce your name correctly. Thank you for being here. Thank you for watching. So barrel connector will be there. So yeah, I think we can start redrawing, basically redrawing the schematic. And there is one important thing. We need to check the bill of material. Oh, okay. No. What did I do? I moved the... Okay, I know. Now I understand. When you share open source project, my recommendation number one is use open source formats. If you share your project using closed source Altium Designer and Microsoft Excel, it's not an open source project. So we have the bill of material here. I did it because I want to know the footprints, the sizes. So I will check when I will be working on the schematic in the split screen mode. So here is the original schematic, here is our working schematic, and let's go. I don't know. I don't know how it ends. Mounting pin, okay. Here is the barrel connector out of my library. They use the 𝗏54 by 𝗦𝘁𝗿𝗃𝗏 diode, 𝗏𝘁𝗏𝗃𝗏, I guess. D1. SC59, okay, so I will use a bigger package. Yeah, this one. Yeah, this is a dual diode. I can see that the original part number is here. Let's check it. Yeah, it's SOT23, and the schematic is definitely not reflecting the real the real thing. What I want to avoid is using 𝗏𝗶𝗄𝗃 components. Why? Usually they are on shortage these days, and nobody knows how it will be in the future, so I don't want to use them anymore, and I'm avoiding using them in my designs. So let's check the date. Yeah, it's great. 𝗏𝗏𝗃𝗃. Hey, it is how it is. When you want to sell your manufacturing to some Asian dictatorship, you can't expect anything better. This is how it is. Where is the central point? Here. Okay, this is our switcher. C plus minus, this is the switching capacitor. C7, let's check the material and details of it. C7 is 0805, 1 micro to 50 volts, on 50 volts, X7R. Okay. I think I have similar one or better in my database. 1 micro. Yes, this one. But I have to check the material. This is X5R. This is not better. Yeah, let me check it. Otherwise, I have to use a different one. Material here. Okay, so we have to use the complete part number. %20 capacitance, but there's, wait, dimensions. Yeah, this is the metric dimensions. X7S. Okay, that's good. That's, I think, even better than X7R, or at least of the same. No, not better, worse. 22% plus minus, and XR is 15, but I don't want to add a new capacitor into my database, so I will use this and this one. But what I want to do is to add the material notice in the description, X7S. That's how it should work. Okay, so this is the switching cap between C plus and C minus. Yeah. Update. Okay. There is V plus, RT, and mode, and 𝗞𝗿 to ground. So RT, 𝗞𝗿, and mode to the ground. And when speaking about the V input and enable, we have to check the data sheet because we have to know where to place the decoupling capacitors. The recommended or typical application by linear/analog devices says that 10 micro on each side is like a typical usage. For micro 7 here. Okay, so let's say we have to be in the upper microfarad region. I don't know if the designer intended to use the 22 micro. In this case, I should check the design files. For the Gerbers. Yeah. See, when you want to save your time, it definitely wastes other people's time. So we are interested in silk screen, not in copper. This is the bottom silk screen. This is upper silk screen. No, no reference designators. That's even better. My guess is that 22 micro should go to the charge pump because, and the high quality cap, I guess, C10. C10, 11, tantalum. Okay, that's something we need to check. Sometimes linear recommends tantalum. High ESR capacitors such as tantalum or aluminum will have higher input noise than a low ESR ceramic capacitor. Therefore, a ceramic capacitor is recommended as the main bypass capacitance with a tantalum. But we are speaking about input-output capacitance action. So they say ceramic capacitor is recommended as the main bypass capacitance with a tantalum or aluminum capacitor used in parallel if desired. Okay. To simplify things, yeah. My apologies. Here is VCC and VEE. That's not definitely V plus and V minus. V plus and V minus is only these two capacitors. My apologies to the designer. This time it was easy to understand, but it took me some time. C22, C22, 0805, X7R, 50-volt rating, and used in doubles, it looks. This is such a cab. Yes. So two caps on the input. Yeah, delivery guy for my components. Please give me a sec. As I said, this stream is a mess. Delivery guy with my components is here in 3 minutes. Because today I feel like a beginner, and if you don't want to be a beginner, you can check this 𝗏𝗏𝗀 KiCad for Beginners course. This is my course, and you will learn everything you want. Please give me a minute, I'm back. Okay, thank you for your patience. This is what it is. Originally, the stream was planned for today from 2 p.m. to 3 p.m. I have to reschedule to 3:30 p.m. to, I don't know, 5 p.m. And always when I have a design stream, a delivery guy or a call must come. Oh, no, anyway. So 447 at the input. I will do it this way, yes. So we have V plus, double capacitor battery. Here, enable, I just want to check the maximum voltage on enable input. $36, that's good. And the output is the same as input, so we can copy these two capacitors, and the output is V minus. Yes. So this is our charge pump, inverting the input voltage. So here should be 5 volts, about 5 volts, plus 5 volts to be precise, and here slightly less, but 5 volts is again. Thank you very much, Agnes. Yes, that means the world to me that you like my content. Thank you for being here, and thank you for watching. So double LDO, which is TPS7A. What happened? Nothing happened. So 10 nanofarad from noise reduction output C9. C9 is 0402, 10 nanofarad 25, and material is X7R. Okay. What was the voltage? I forget. C25, okay. 25, and we can use NPO, it's even better. I want to edit the volt value, but the position. Oh, okay. in is what? Is negative input. Okay, so there should be some decoupling cap. Let's check the data sheet. Oh, now I understand the schematic. There is probably one for micro 7 for the charge pump, and the second one is for the LDO. Per microfarad or greater, 2.2 micro or greater of effective capacitance. Okay. Our 4 micro 7 at 50 volts should have enough capacitance. Okay, so it seems that these two two of them should be at negative and positive input. Probably. I'm not a designer, and probably yes. No, this symbol is not good. I don't know if today is a good day to design anything. I don't know where is my schematic. Again, I always recommend to check the maximum input voltage on the enable. Usually we connect the enable directly to the input voltage, but sometimes the maximum limit is lower than the maximum limit of input voltage. So I did a similar mistake in the past, and it's not good, especially when you use the pin compatible devices by different manufacturer, and they differ in the absolute maximum ratings. For instance, Texas Instruments allows you to use the same input voltage as on positive input voltage on enable, like this, like here. But for instance, you have to use, as in the during the pandemic and the component shortage, I had to use, I don't know, Realtek or some similar component. The same pinout, same package, everything was pink and green and easy, but the maximum input voltage on enable input was 6 volts. And I supplied the switcher from, I don't know, 24 or 30. So be careful. And since then, I always check the maximum voltage on enable input, because when we like mindlessly connect anything directly to another net, we have to be 100% sure that that particular input withstand the voltage on that main net, like the input voltage. So I believe you understand. I believe you do understand, but I do not like this symbol. I think I created this symbol, which is why I blame myself. Okay. Yeah, what was wrong is that the SS letters was like touching the GND text, the GND label, so that was nothing I want. Yeah, definitely. We have to check everything, because it can make some big headaches. The issue I mentioned was solved by lifting the pin of the SOIC 8 package, because luckily the enable pin on that replacement part had the weak inner pull-up, and it can be allowed, it was allowed, the pin can be left floating, so that repairs the entire manufacturing series, but I didn't do a good job, and I wasn't happy about that, but it is what it is. Thank you for the comment, Manuel. Thank you for being here. Now, output 10 nanofarads both, and some feedback resistors. We have to check, at least I wanted to check the output voltage, because the feedback resistors are of a different resistance, and that's something that concerns me. So yeah. C6, we have 10 nanofarads 0402 here, so I guess this will be the same. C6, let's check. C6, yes, that's the same. Good job. I would do the same to simplify the bomb. What can be simplified should be. In any phase of the design, even when the prototypes are tested and manufactured and tested. Anyway, the unoptimized BOM means extra money, wasted money. Again, feedback resistors. So let's start with the positive feedback resistor. So we have a data sheet here. We can start with the threshold voltage or reference voltage for both. Here is 1.188 typical, and negative feedback voltage is 3.7 millivolt. Okay, that explains why these resistors are of a different resistance. Let's check the application and implementation, because I think I saw their tables. Yes. So we have, things get complicated. 10 kilo ohm on the bottom and 41 is the upper. So 10, 41, 10, 41. I'm not muted, I just thinking silently because I don't know. This is LDO. It means that the output is lower than the input. And we want 5 volts. Not 5 volts. Yes, we want 5 volts because the buff, the high speed op amp 𝗏802 have input voltage, recommended input voltage of ±5 volts at max 6.5. It means that the LDO output is let's do a quick math. So we have 1.188, we have 10K2, am I right? 10K2 and 41.2 is here. Yeah, 6 volts. 6 volts is the designed output voltage. Okay. Okay. And frankly, okay. The buff input is what? Buffered reference output. This pin is connected to FBN through R2 and the voltage at this node is inverted and scaled up by the negative feedback network to provide the desired output voltage. The buffered reference can be used to drive external circuits and has a 1 milliamp maximum load. Okay. So again, we have from buff to negative to feedback, from buff to feedback is R2N, and R2N is 18K. R2N is 18K, they have 10K perfectly. So the other resistor should be 1.8 times higher. So if we have 91 in the table should be 50.5. Yeah, it looks like 6, -6, okay. I will use the same components because the device is tested, but I'm not happy with how it looks. But why I'm here to criticize. So 91, I think I don't have, yeah, I have 91. From output negative to feedback, 91. And 18, I have to add the, and create 18K. Okay, so let's start with this symbol. No, 91. Okay, and 18. No new symbol, save as. Be careful, sometimes the definitely lower expensive, and sometimes higher on stock resistors are usually 5% ones, and you don't want it usually. So from buff to negative feedback is 18K. To keep the schematic like sane, okay, 10K2. My favorite registers are 𝗂𝘂. So this is why I only looking for 𝗂𝘂. It doesn't mean that 𝗂𝘂 are better than Panasonic or Samsung or I don't know, Burns. It only means that I like the 𝗂𝘂 more. One reason is that the part number is smart and you can generate your own one. If you are looking, for instance, for a new value, you have 10K and you want 12K, so you change 10 to 12 and the part number usually works. Yes, you have to verify it, but that's my thing. I don't know if you understand. And 41.2. We can check my theory now. You can see that we have 10K2, which is the same range, or the same I think range as 10K2, so we can create the 41.2K just by changing two numbers in part number. Doesn't mean that it doesn't mean anything. You just save, I don't know, 10 seconds. Maybe more. Aha. Okay. Fine. So we have bottom is 10K from feedback to ground. This is our output cap. 10K2. The schematic is crazy. But I will do some cosmetic work at the end of the job. The symbol is awfully stupid. The symbol is not only a bunch of wires and lines, it's a helper to create nice looking schematic. So I recommend spending some time polishing it because it always pays off, in my opinion. VCC and VEE. There is a LED. Okay. No. No. I wanted my favorite 0805, this one. Okay, 7 can be like, no. I will use this one. GLC PCB uses like notation not 2K2 but 2.2K. It's again something that can save a little bit of your time. Okay, so we have the power supply. Think. But we have 10 nanofarad only, and they say 2.2 microfarad or greater input. I don't know how to. Okay, probably no. Processing the design. I'm importing the files into the Altium viewer just to check the PCB, because I don't know where to place those decoupling capacitors. This is the diode. No, trimmer. Aha, trimmer. Here is the diode. Yeah, there's the wrong symbol. Here is the LDO. Yes. And the LDO have, that's something, I don't know. I don't want. Okay. Input voltage is pin number 1. Pin number 1 is here. And here is the input capacitor of 4.7 micro, okay. And VCC is the output capacitor of 22 microfarads tantalum. Okay. Ceramic. So 22 microfarads are for the VCC and VEE. Okay, these are the feedback resistors. Here is the 10K2 for yes, and 10 nanofarads, which is between VCC and between pin 10 and 9. Pin 9 is okay. Yeah, I'm wrong. I'm wrong as hell. Yeah, I'm sorry. I'm really sorry. The 10 nanofarad capacitors should be on completely different location. I was very wrong. So this is VEE capacitor. I don't know how to draw the VEE. It's lower than ground, so I don't know. I don't want to be creative. Okay, so we have the LDO, and the entire bunch of capacitors goes to somewhere. So let's locate the 𝗞𝗶𝗖140, which is U2 in the Altium. This one VCC is 10 nanofarads. No, 100 nanofarads. So two 100 nanofarads. My pleasure. 1, 2, okay. Then we have, let's check again. This is the trimmer. This is the feedback network, probably 62 and some big resistor. Yes, the input network. Okay. And U1 is here. Yes. And VCC is here. 10 nanofarad. This is probably a designer's favorite capacitor. Low inductance capacitor, I understand. I really understand. Okay. Expensive like hell. Twelve and 1. Number 12. No pin numbers, like why? Okay, so 2 of them. 𝗬𝗫 only. C14. 𝗬𝗫 in the original design. No, I was wrong. C14. Indeed. C14 is the 0603, the reversed low inductance capacitor, ceramic capacitor. And the order code is a normal 0603 standard. So there is a mistake in the BOM, the original design. Yes. If we want to use the low inductance input capacitor, ceramic capacitor, we have to use this 𝗬𝗀 because nobody else, I don't know if nobody else. Low inductance chip capacitor. Okay, this is the intersection. Yes. 100 to C14. I don't know if we can believe that poem because there is a mistake. 25, let's say. Here. 25 X7R. 06. Okay, so here. Non-stocked. Non-stocked means our show is stopped. I want to clear this filter. How to do it? So okay, there is a wrong picture. Okay, at least. Okay, that's LICC. Okay. Okay. It's not so easy with two regulars because there must be zero, I don't know, zero smaller than 0402 because yeah, the package is reversed. So the normal 0603 100 nanofarads 25 volt 67R impedance characteristics is that the resonance frequency is at about 10 megahertz. Yeah, this is impedance, this is Q, 10 megahertz. And when I see this one, this is lower than 10 megahertz. It means that, in my opinion, the inductance is higher. Because, no. Am I right? No, I'm not. Yeah, I'm right. The inductive character starts taking place sooner. So I will use the regular 0603, not this crap. And I will use two packages and this is the similar one, but probably without impedance characteristics. I will use the 25s for the buff because I just verified that these two are good enough. Okay, and 10 nanofarads C18. Yes, the same as before. It means this one. Here and here. Yes. Okay. Okay, so we can draw the power entry for VCC. Is it VCC? Yes. CLH is what? Okay, something different. K, R17, probably 0402. Yes. CLL is the same. As CLH. Okay. And probably because of the inductance, all the passives will be 0402. I don't know. Yes, probably yes. This is what size of the package? Zeros, okay. Only small packages here. Okay. And here? LED, okay. And the trimmer? What type of trimmer is it? And what the trimmer do? What the trimmer does? Here. Okay, some gain adjustment. No, show me the yes, this one. Yeah, PVG3, okay. I don't know if okay, we'll see. Let's start with the passives, like the input network, 10 meg. I will just check if R10 if it's a regular resistor or not. R10, yeah, a regular. Yeah, go. Yeah, similar as I use in my library. For instance, here. Yeah, from bias. Zero ohm. C1 and PO probably. Yes. Different. It's different material probably. Some crap. Okay. It should be some RF Murata, I think. This one. Yeah, it seems like standard general purpose, okay. Anyway, I will use this one. 50. This is our cap. So what else? Some artificial values I hate. Okay. Let's create some exotics. 422. $1.6 mega ohm. 𝗏𝗶𝗊1 and 𝗏𝗶𝗊3. I think these are from RF. Yes. But we need 1.1 non-stocked. This one. Slightly different, but oh. I want 200 volts capacitor. Okay. I will read this one. Not the same, but and 1.3. So hopefully non-stocked. What a happy day. Did I use the correct package before or not? Yes, I did. That's not correct. What I do is not correct. Because I am assigning 50 volt capacitors to my library of 200 volt, but it's the 𝗏𝗀𝘀𝗶𝗶 code only, and it's not correct what I'm doing, but yeah. 1.91 mega ohm. No, show me. I wanted to use schematic today, but I don't know if it's possible. Okay, I will finish here and continue next time. Does the PCB like stopped working? Okay. We are almost 2 hours in the show, and I think it's not reasonable to continue because there is a lot of work. I will need to work on the trimmer and some other exotics. So I will stop here and continue next time. Just a sec. Okay. Yeah, I think we are on the good track. Just a few components. Almost all must be created because the values are not quite common. But it doesn't matter. Thank you for being here. Thank you for watching. And next time we will continue with the schematic, and we have to identify still the open task, or others the open tasks from last time. Tip spring, loaded thing, tip, like, yeah, sprint loaded thing for a tip, ground pin connection that means for the probe. Power entry connector we solved. There is a DC bar connector and SMA MMCX RF connector for the output that will be identified next time as well. But I think SMA, probably SMA, it's better. Edge mounted SMA, I think, will be our choice. We will see. Yeah. Thank you for being here. Thank you for watching. See you next time. Bye bye.